and it was muted. I didn't even catch it, but I did catch it on here. So anyway, I am streaming tonight for my class, my face-to-face statistics class, and I have given them an edict that if they show up tonight, they will earn 7 points towards either the quiz weighted category or the test category, and all they have to do is interact with me. They got to let me know who they are, because I won't know from the screen name sometimes, but just let me know who you are. Oops. I didn't catch it, but I did catch it on here. So and then once we determine that, and they not only have to ask me a question in the live in the chat, but they also have to post it down below, because I'm trying to figure out the algorithm to this thing, if comments make a difference for it to take off, and how that can be set up where you can get more interaction within what we're doing here. So again, I'm on Restream, and I am streaming from an online class. I got calls coming in and stuff. I apologize for that. Let's get started. So tonight I'm doing a review, normal distribution. So I did a little bit of this on Tuesday. I'm doing more tonight. And if my class comes on, I'll answer any questions they've got. That's actually what this is for, is online office hours. But while I'm here, I will go through a few problems and do something for video on demand for the Moodle. So let's talk about SAT writing scores. And let's say that the SAT writing scores have some mean. In this case, In this case, it is 493, and the standard deviation is 111. This is what we're working with for our normal curve. These are our baselines. And we're going to be looking at the SAT writing scores. And what we want to know is if a score is selected at random, or a student score selected at random, then what is the probability that score would fall between 200 and 450? So I want to know if it's 200 and what the probability is it falls between 200 and 450. There's a few things that I have to do. Number one, I'm going to set that up. So I'm going to set it up in terms of a probability. And so the probability is going to be that X falls between 200 and 450. Okay, so there's that. I can't just work with this openly like this, which actually we can. There are syntax within the calculator that allow us to work with this. But the way I've got my class set up, I try to force my students into determining what the z-score is first. And then as we move forward in that, we rewrite it in terms of a standard normal distribution and working with z-scores. So I'm going to rewrite this probability expression. Instead of the probability of randomly selecting a score and it falling between 200 and 450, I want to know what the probability is that the z-score that corresponds to that x, or corresponds to those two values, what the probability is that falls between. So I have to find the z-scores at 200 and the z-score at 450. So I'm going to just work right over here. So my z-score form is derived in class, and we've used this quite often since really the first part of the term. We take the x value that we're looking at, subtract mu, we divide by the standard deviation. Well, we have the x value, right? It's here, and it's also there. We're going to work with two separate ones. And we also have the mean and the standard deviation. So I'm going to start with the 200 first. So I'm going to go 200 subtract 493 divided by 111. Now that's going to be a negative number, and no surprise that it's going to be negative because it falls below the mean. It's down here, closer to the negative infinity side of things. So it's negative in sense of the z-score because it falls to the left or is less than the mean. So what is an exact answer here? Let's go 200 subtract 493. And I get minus 293, and then I divide by 111. Negative 2.64 is what I've got here. So I get negative 2.64. So that is the z-score equivalent. In other words, the 200 representation on this normal distribution is equal to the negative 2.64 on the standard normal. The 2.64 is, of course, what we're going to work with. Now I need to do the same thing at 450. So let me go ahead and erase this out. And we come back up here, and our x value in this case is the 450. So I go 450, subtract 493. Still a negative number, still on that side as you're looking at this normal curve, still on the left side of the mean. So it's going to be negative in terms of a z-score, and that's all divided by the 111, which the 111, the mean, the mean and the standard deviation were both given. They were given in the problem. They were given in my setup for tonight's first presentation. So I have 450, and I subtract off 493, and I divide by 111, and I get negative 0.39. So that's what I'm going to put here. Whoops. Negative 0.39. So there's my z-score equivalent to this. So now I go back to these question marks because they corresponded to the particular values from the set. And I now have what is the probability that z falls between negative 2.64 and negative 0.39. I'm going to do a little bit different tonight. I'm going to actually use the calculator, but I'm also going to use the table. I've got the table brought up in Adobe Acrobat, and we're going to use that, but I just have to make sure that I keep I got to switch screens, so I got to make sure I got these numbers down. And here's how we approach it. So I can get rid of this because we've already determined what my z-score equivalents were to the outer pieces of that area that we're trying to find. And so now if I was doing this on the calculator, I will put the syntax up here in just a second, but before we get there, I'm going to talk about the fact that we are going to find the area from here to negative infinity and from here to negative infinity. So we're going to go from here all the way to negative infinity, and I'm going to go from here all the way to negative infinity. Now, there's overlap here. And what I'm going to end up doing is I'm going to subtract one area to the left all the way to negative infinity from the other one. Lost my place. There we go. So I've got this area and I've got this area, and the overlap between these two from here back, I'm going to subtract that off, and that's going to leave me this area here. Now, not outside of the curve, certainly, but in here. It's going to leave me this, and that's going to give me the area between 200 and 450. So let's go find that. I've got negative 2.64, negative 0.39. I've got them right over here. Okay? Sorry about that. So I'm on my standard normal distribution, our table of values. This table represents the area to the left of the z-score. That's what we've been working with in class. So I'm looking at negative 2.64. So I have negative 2.6 right there, right here, and then I have 0.04 up here. So it's going to correspond to right here. So it's 0.00415. So 0.00415. That was from negative 2.64. So now I'm going to look at the area to the left of negative 0.39. So I'm still on the negative side, so I can say negative 0.3 right there. And then the 9, if you look at the column up here, it's going to be that very last column. So I've got the negative 0.3, negative 0.39 is right there, 34827. So I've got both my values that I need. I now go back to my work. I've written those in there. So I'm going to take this value and subtract that value from it. What I'm left with is going to be my area. Then we're going to switch to the calculator, and I'll walk through the calculator real quick, verify this. So I'm going to go 34827, subtract 0.00415, and I get 34412. So I'm going to write that up here in purple. So I get that the area is 0.34412. I'm saying that's the answer. I'm going to verify that with the calculator. So let me erase some of this off, And the reason I'm taking this off is because I'm going to put the calculator syntax over here. All right. So the calculator syntax, once I go to it, and I'll switch to it in a second, I'm going to go second vars, which is the second function of the vars key, which is distributions. I scroll down just a tad down to normal CDF. You're going to have a parenthesis. In that parenthesis, the way I do the syntax is I force the students to find the z-score, and then I'm only finding the area between the two z-scores. So in this case, it's going to be between negative 2.64, which is my farthest left as I'm looking at it, comma, negative 0.39. Negative 2.64 to 0.39, we'll find out what that area is. And here we are. So I'm going to go second. We'll clear that. So I've got second vars. Scroll down to normal CDF. And you see there's another syntax right below that on the particular emulator that I'm using. But again, I'm only going from one z-score to the other and finding the area in between. So I go negative 2.64, comma, negative 0.39. Double check it. Yep. And I get 34412. Okay? 34412 is exactly what I got right there. So I verified it with the calculator, and I used the table to find the initials. So that's working with the normal curve. So again, computational tonight. And let me bring up chat, because I may have missed, I see somebody is in here, so I may have missed somebody. If you're in my class, don't forget, you got to let me know that you're here so I can write it down. It's a +7 toward the quiz or the test category tonight, just for being here as we wind down the semester, try to improve one of those two categories. Okay, I've just walked through an example piece by piece with the SAT writing scores example. Now let's move on to a second one. SAT math. Why not just keep it within the family? And if you noticed a second ago, this is an older problem that I had from the Intro to Stats textbook. I like these problems. And they're set up very well in here, but I just went ahead and redrew them so I could work with them and walk through with you step by step. So, now we are looking at if we randomly select a score from the population of students who took the SAT math, what is the probability that we get a score that falls between 670 and 800? In other words, what's the probability a student will get that score? Well, we're working with pure numbers there. We have to change that to a standard normal to work with it in our computations. So I'm going to start by changing this to a z-score, changing that to a z-score. I'll start with that this time. I won't write the expressions out just yet. And keep in mind that we do have everything we need right here that defines our normal distribution with these SAT scores. So I go z-score is equal to x subtract mu divided by the standard deviation. In the case of the 670, it's going to be 670 subtract the mean of 515, which is right here, and then divided by 116. So this is SAT math, so there's going to be a different mean, different standard deviation for this different test, or this different portion of the test. So I have 670 subtract 515 equals 155 divided by 116. I'm going to go to two places, 1.34. So I get 1.34. 1.34 there, less than z, less than, now we just need to find the 800. We do the same thing. Apply the same formula that we derived in class. I have 800 subtract 515 divided by 116. So I take 800 subtract 515, that equals there, and then divided by 116. 2.46 looks like. So I get 2.46. Now I can erase all this out. I'm moving a little bit quicker pace here. So I have what I need. Now I'm going to write my probability statement just to be formal about this. I'm going to set that up. So I'm looking for I still only eraser, I'm sorry. What I'm looking for right here is the probability that some z-score falls between 1.34 and 2.46. Applies to a myriad of problems. In this case, our context is SAT math. So I can find this with the calculator, or I can, as I go back to what I did previously, I'm going to do that again. I can find the area from here all the way to negative infinity. I can find the area from here all the way to negative infinity. And of course, as before, I'm going to erase all of this from all of this, which just leaves this. This part is what's going to be left. So I'm going to subtract off that other part. So the way I do that is find that using the table, and then I just simply subtract it. So let me scroll here. So I've got 1.34, enter, and I've got 2.46. So those are my two numbers I'm working with. I just want to make sure that when I go off this screen to my table, I'm okay. So I need to go to my positive side. I was on the negative side last time with the negative numbers we were working with. And so I'm going to scroll down here to the flip side, the B side if it was a record back in the 70s and 80s. I'm going to flip to this side, and I'm going to go 1.34. In other words, to the left of 1.34 to negative infinity, what is the area? So I have 1.3 here. I have 4 right there. So we are looking at 9988. So I've got 0.9098. 90988. Yeah, I wrote it right. Okay. Now we're going to look from the 800, which is the 2.46 from a z-score. So I've got 2.4 right here. And I was right. It's right here. The 6 is right here. 0.99305. 0.99305. So now I've used my table. Now I go back to my work. I've already written these in here. I'm going to subtract. So I've got 0.99305 subtract. Just going to use my calculator to do this. 0.90988, 90988, 99305. Double check it. 0.08317. 0.08317. 0.08317. I'm saying that's the probability out of that. Okay. So now let me use the calculator, and the calculator syntax, in other words, let me erase this out because we're done with this piece of it. And I actually don't need to erase that, but it's okay that I did. So now I'm going to work with the calculator, and as always, I'll walk through the calculator syntax with you. It's second vars, which gives you the second function of the vars key, which is distributions. Scroll down, I think it's to the second or third down, and you get normal CDF, CDF being a cumulative density function because we are working with this normal distribution, all the values along that horizontal. And I'm going to go from the farthest left, 1.34, to the farthest right in this particular case. So calculator, find the area from 1.34 to 2.46. Let's see if that corresponds to what we had up here. So I go second vars, whoops, let me scroll to it. Actually, let me hit clear. So I go second vars, scroll down one, just one down to number 2, normal CDF, and I go from 1.34, comma, 2.46, 08318. 08317 or 0.08318 if I had your round down there. One of those would get you exact. The other one would be as exact as we need it for this problem. So 0.09318, because the numbers we were working with in the table were out to 5 places, and the numbers we're working with here are further out. So we're going to get a little bit of discrepancy with that 7 and 8 at the end, but that to me is not a discrepancy. That just shows us that's just talking about how accurate we want to be right there. There's what the table got us, and these are the two values depending on whether you're round or not that the calculator spit out. I'm good to go with that. So I hope that helps you. I have been online now for I I'm not sure how long because I'm on the wrong screen. I've been online now here for about half an hour. Nobody from the stream is showing up. Somebody's on the chat right now. It says, "Hey mate, you're doing an awesome job on your stream. It's really great to see you. Love to connect. Just want me to get with them on Discord." That's not happening. But I appreciate you stopping by. They stop by every time. So I have walked through two problems. I walked through an SAT writing scores problem. I walked through a second problem, SAT math. I used, in this case, different from the other night, I used the calculator and I used the table to work through them. We have an assessment, we have a test coming up this next Wednesday. I encourage you, the homework that is due for this next Wednesday, and we'll take the quiz on Wednesday because I didn't take it the other night. I let you go without it because I was having a hard time with hydration. So we'll take that quiz next time on the vocabulary and the formulas. We'll take the test at the second part of class. We'll continue with our discussion of the last topic that we will cover in this course before the final, which will be 2 weeks from last night. So thanks for stopping by for the video on demand for my class. I'll post it on Moodle. It's always on my YouTube site. Nobody came for the extra 7 points tonight. I am disappointed, but I have another live stream scheduled for next Tuesday, and you're certainly more than able to come then and do the same thing. You'll post it in the comments, and you will talk with me, at least in chat, about some question that you have. Other than that, I am done for the evening, and I appreciate your time, anybody that stopped by and anybody that comes back to the video on demand. Thank you so much. All right, take care.